section 1.3. Okay, so first of all, we need to understand what is a midpoint. Okay, so we're just going to kind of loosely define it here by filling in these blanks. Guys, I need those side conversations to stop so we can get through this quickly. The midpoint is located at the blank of a line segment. So first of all, make sure you understand that it has to be a line segment. You cannot have a midpoint of a line or array because those go on forever, right? So it has to be something that has endpoints. So a line segment, what does it sound like a midpoint would be, or where a midpoint would be? In the middle, right? Now, not just randomly in between, but the exact center. So I'm going to put center. Okay. You can put middle or center, however you want to do that, but just know that it is the exact middle. So they're on top of the shelves there. Grab one. Okay, so it is the exact center or exact middle. Okay, it cuts the segment in half. Okay, half means 2 equal parts. So in what we've been talking about in geometry, when parts have equal measure, remember those are called congruent. Okay, so a midpoint is at the center or the middle of a line segment. It cuts the segment in half, creating 2 congruent pieces that are equal in length. Okay, so this graphic here, you can come grab the outline back here. This graphic here shows that with markings. Okay, so when we are marking figures on top of the shelf there's a stack of them. We use tick marks. Okay, so this is a tick mark. Okay, just a little dash on the segment. So this is saying that from point A to the midpoint is the same as the midpoint to point B. Okay, they have the same number of tick marks. Okay, if you need to make note, like a little side note, okay, we use tick marks to show congruent. Okay, those are called congruence markings. Okay, and as long as they have the same number of tick marks, they're congruent. So for example, I could have 2 tick marks here and 2 tick marks here. That would mean that those 2 segments are congruent. Okay, on our image here, they put 1 and 1. You can put however many tick marks are needed. Some figures have lots of sides, and so you'll see different amounts of tick marks, but you're looking for the ones that match. So 1 and 1 means these are congruent, or 2 and 2 means these are congruent. All right, how do we find the midpoint? Okay, if I want to know the exact middle, if I have a horizontal or a vertical line, okay, on a grid, these are on a coordinate plane, okay, it's pretty easy if it's perfectly horizontal or perfectly vertical, because I can simply count how far the endpoints are, how long the segment is, okay, and then I can find the middle, cut it in half, cut that distance in half. Okay, so I'm going to write that down. If horizontal or vertical, so straight up and down or sideways, on the coordinate plane, you just have to count. Okay, pretty easy. So let's count on this one. So the total distance is 1, 2, 3, 4. Okay, so the distance is 4. Okay, so what's half of 4? So I'll go over to 2. 2 from the left or 2 from the right. It doesn't matter what direction you count it in. So I just counted the distance and cut it in half. Okay, so now I need to give the coordinates here. That midpoint, remember your coordinates are X and then Y. Remember, it's how far left or right, and then how far up or down you are from the origin. So this is at 4, 2. So that's the midpoint here. I didn't have to calculate anything. I just had to count, okay, and then find the halfway point. Now, if your line is drawn at an angle, it's not perfectly horizontal or diagonal, okay, but we're still on a coordinate plane, okay. Who remembers? Let's see. Actually, we don't need to get into that yet. Let's still just count here, okay? But you're going to have to count, okay? If it's at an angle, you're going to have to count both X and Y distance. To find the middle. Okay, so let's start with the X distance from A to B. Okay, so that's 1, 2, 3, 4. So we went over 4. But then I also need to count my vertical distance. That was 1, 2, 3, 4. So that means I'm going to have to horizontally, left and right, go over 2 and vertically come up 2. So I'm going to go over 2, up 2. So that's going to be the middle, right? It's the vertical center and the horizontal center. Do y'all agree? Okay, so this is at 4, 3. Yes. Oh, yeah, they're back here on the shelf, the top of these shelves. You can come grab one. Questions on if it's on the coordinate plane, how you can simply count to find the center? Y'all remember to use X and Y to name your points, right? Or to give the coordinates of your points? Okay, now what if it's not on a coordinate plane? Okay, what if we don't have a graph of our line segment? Okay, so we're going to have a formula. Okay, the formula for midpoint, okay, you have to know the location of your 2 points, which we call x1, y1, and x2, y2. And then we are going to find that distance with a formula instead of in a picture. Okay, so what we're going to do, that's a little long. Okay, we're going to find the difference in the x's. That's what we did up here in green. We counted the horizontal distance. We were finding how far apart they are. With an equation, you're going to take your x values and subtract. So I'm going to do x2 minus x1. Okay, how far apart are the x's? And then up here, when I had a picture, they were 4 apart. What did I do with that 4? To figure they were 4 units apart. And then what did I do with that? To figure out how far over I go. I divided it by 2, because what I'm doing is finding the average, okay? Oh, I'm sorry. I'm supposed to add there. I put a minus. I'm going to add those 2 x values. And you can put the x1 or the x2 first. I've gotten in the habit of always writing x2 first because later, tomorrow, we're going to do distance formula, and that's when we're going to be subtracting. And so I just keep it consistent and always put x2 first. But because you're adding, it really doesn't matter. But you're going to add your 2 x values. And then, like I said up here, we divided by 2 to see how far over we went. We're going to do that here as well. We're going to divide by 2. Okay. And then we're going to do the same thing with our y's, okay, to get the vertical location. Okay, so we're going to take our y values and add them together. and divide by 2. We are literally finding the middle, okay, which is the average of the horizontal location and vertical location of our endpoints. Okay, so remember, average, you add up what you have and divide by how many there are. In this case, there's 2 endpoints, so we add and divide by 2. Okay, good with the formula? Everybody wrote that down? All right, let's try that first example. Okay, so we don't have a picture, but we're given the coordinate. So I'm going to label those as x1, y1, and x2, y2. Okay, so those are the ordered pairs that of the segment GH. Okay, we have the location of G and the location of H. So I'm going to use my formula. And find the location. So I can add my X values. You can do 9 plus 7 or 7 plus 9. It does not matter, but those are your X's. And then for your Y's, you've got a -5 and a -1. And again, it doesn't matter because you're adding, so you can put them in whichever order you want. Okay, so what's 9 plus 7? 16. And what is -1 plus -5? We've got -6. Okay, now we have to divide both of those by 2. What's 8, or excuse me, I said it. 16 divided by 2 is 8. And -6 divided by 2 is -3. So that's the location of the midpoint. That would be the exact center of those 2 points. We feel okay about that process? Now I wrote all that out showing each individual step. Okay, some of you are going to be able to kind of do that all in one step. You're going to say 9 plus 7 is 16 divided by 2 is 8. And you're just going to jump straight to the 8. You might not have to write this middle step, and that's fine. Okay. So let's set it up again. Let's try this one. Okay, what are my X values of my endpoints for AB? -7 and 3. And put those in whatever order you want. Make sure you have the sign with it. And then my Y's are 4 and -4. Okay, so when I go to add those, -7 and +3 would be -4. -4 plus 4 would be 0. -4 divided by 2 would be -2. And 0 divided by anything is what? 0. So that is the location of the midpoint of AB. Now, example 3 is slightly different because this one says to find the point that is half the distance between. It doesn't say the word midpoint. You have to know what a midpoint is. So isn't that what it's asking for? Half the distance between these points. Now, if it had some other fraction, if it said 1/4 of the distance or 3/4 of the distance, instead of dividing by 2 like we do for midpoint, you would, if it was find 1/4 of the distance, you would divide by 4. If it was 3/4, you would divide by 4 and multiply by 3. Whatever the fraction is, that's what you're multiplying that sum of the X and Y by. Okay, but this one is half, so half the distance between still means midpoint. Okay, so if you need to write down that means midpoint, you can write that down. So we're going to do the same thing one last time here. So my x's are -5 and 1. My y's are -2 and 2. I'm going to go ahead and do this in one step. -5 and +1 would be -4. -4 divided by 2 would be -2, right? What's 2 plus -2? 0 divided by 2? Still 0. So this is the midpoint this time. Ended up getting the same midpoint as the other one. That's okay. All right, back to the coordinate grid. Okay. This one says find the coordinate of A if M, which is at -1, 2, and it's already plotted at -1, 2, is the midpoint. So M is the middle. We're given the midpoint this time, and we're given one of the endpoints. Okay, so B is at 3, 2, and it's already labeled. So they're telling us that this is half the segment. So where do I go to get the other half? I'm not looking for the half of this. Okay, AB is the segment, M is the midpoint. Okay, so if this is the middle and I have the point to the right, where do I need to go from M? Left. How far do I need to go from M? Yeah, I need to go the same distance that B is. Okay, so I'm going to count out the distance here. That's 1, 2, 3, 4. So I'll have to go 4 in the other direction. 1, 2, 3, 4. So there is where point A should be. Does that make sense? So then I could finish drawing the segment AB. So the total length is 8, because this was 4 and 4. Now, what are those coordinates of A? Good. X, Y. So -5, 2. So graphically, on a coordinate plane, I was able to simply count again. I didn't have to use the formula. But I want to show you, you can use the formula and go backward as well. So I'm going to add an example. Do you have, I can't remember how much space is on your paper. Is there a little bit of space underneath there? Yeah. Okay, so I want you to add an example. Would this be 5? Example 5. Okay, point A is what we want to find, just like this last one. So find point A if M, somebody pick a point for us. Give us some coordinates, not too big of numbers. We don't want to make it too hard on ourselves. 6, 2. So let's say that's the midpoint. Just going to abbreviate midpoint. Segment AB. This to be an and. B is at, somebody pick another point. Lovely. Let's do it. Okay. So if I don't have it graphed, well, one, you could always graph it. I have scratch graph paper back here, and you're welcome to graph it if that's your preferred method. But we can also use the formula. Now, what we plug into the formula, it may just go backward because normally we have our x and y's of the endpoints plugged in, and it equals our x and y of the midpoint, right? So instead, we would work backward and we would say, oh, the midpoint we already know. Okay, and then I know the x of one of these and the y of one of these. So what's missing is this x and this y. Okay, so I could work the equation backward. Okay, now I would separate it out. I'd say, okay, let me focus on my x's first. So this 6 plus x divided by 2 is supposed to equal this 6 right here, right? Okay, and then my y's I'll do separately. 7 plus y divided by 2 is supposed to equal this 2 right here. Everybody agree? So I'm separately finding the x and the y of my missing endpoint. So to solve backward, I would have to multiply the 2 to the other side to get it out of the denominator, because what you do to one side, you do to the other. So I'd get rid of the 2. 6 times 2 is 12. And then how would I move this 6 to the other side? Would minus it. Good. For our algebra skills, we do opposite operation, and what you do to one side, you do to the other. So that would put that at 6. Okay, now over here for my y, I would do the same thing. I would multiply this 2 to the other side to get rid of the denominator, because the opposite of divide by 2 is multiply by 2. What I do to one side, I do to the other. 2 times 2 is 4. And then to move this 7, I would subtract. And then what is 4 minus 7? If I'm at positive 4 on the number line and I go left 7 in the negative direction 7, where's it going to put me? Negative 3. So now I have point A would be at 6, negative 3. So I can work an equation backward if I know the midpoint and one of the endpoints. I can come back and find the other endpoint. That's what I did here graphically. Okay, this was just using it in the formula. So you just have to do the x separately and the y separately. Some of you may be able to count that in your heads without the formula. You may write it down and be like, okay, if my x is at 6 for this one and the midpoint's also at 6, okay, if I were to graph this, this is just this one happens to be a vertical line because those numbers are the same. So I know that the other endpoint should also be at 6 because it's a vertical line. And then say, okay, if my endpoint's at 7 and the middle's at 2, that means I'm coming down from 7 to 2. I went down, how many? 5 from 7 to 2, and then go down 5 more from 2, and that would put you at negative 3. So some of you can visualize or just count that and get the same thing, but I want you to see algebraically how that works with a formula. How we feel about that? Good. Okay, now y'all can get your laptops out and I'll show you where the practice is. I'll go and activate it for you. Let me stop this video. There is a practice for everybody to try this.